get started. So thank you all for coming to attend my session and talk about standardizing cloud infrastructure. So I'm really excited to be here. My name is Youssef Riahi. So this is the first time participating in Nerd Summit. So I appreciate you guys coming to attend my talk. And my name is Youssef Riahi, and I work for the Commonwealth of Massachusetts. I'm a DevOps engineer, so I've been with the Commonwealth for almost like 9 years with the Executive Office of Technology, Services, and Security. So once in a while, we post things to GitHub, so you can check them out. You can also tweet me or email me. So in this talk, what I'll go over the move to AWS and what are some of the issues that we faced and how we went about solving those problems. So before diving into that, so I wanted to give you some background of where our infrastructure was before our move to AWS. So with the state of Massachusetts, so we had infrastructure split up between 2 data centers, Chelsea and Springfield, and we were all based in Boston, and the operations team is basically in a different location. And communication is essentially strictly email and via a ticketing system. So on occasions, we have very low visibility in terms of what's happening with our applications or our servers. And in the case of we needed to spin up new applications and we needed new hardware or resources, so just a very lengthy process for provisioning those servers. And really, like, we also had like a mix of physical and virtual servers. So then we moved to AWS. So, and in that transition, so I want to mention like MDS, Digital Services. Digital Services is born, so I'm going to read this, okay? So our mission is to use the best technology and information to make people's digital interactions with government fast, easy, and wicked awesome.
Is that part of the mission, wicked awesome?
Yes, it is. It is actually part of the mission. Yeah, it is. So, and this, Digital Services was born, and so did a series of projects and products that we need to spin up and make available. So in that environment, so we're really moving fast. So we need to spin up like MVPs pretty quickly. This is a list or like a sample of applications and things we want to spin up and make available. Things like dashboards, making data available from Google Analytics, broken links, and consolidating the data and making it available into the CMS for authors to see, like, I'm looking at this page, okay, I want to see how broken links and how is it doing in terms of traffic and so on. So we were building dashboards, so search.mass.gov, so, and just like any other environment or any, service, you have tons of logins, so you wanted the ability to have central login for all your applications, or at least one place where you want to go and look at those. Other projects involve like licensing APIs, where if someone wanted to check whether, a barbershop license, a hairdresser license, or like a nurse, or any type of license, and someone who wanted to check that. So we had requests for campaign sites, so we wanted the ability to be able to spin up campaign sites pretty quickly. So, and these are some of the examples, like Chapter 55, the opioid campaign site. We also had the budget site, really high-profile site, the budget. So every year, so we, the governor's office publishes data about the budget coming up for the next year. So when you're moving fast, so like a lot of the focus goes into like making the product available out there. So, and a lot of the things sometimes get overlooked. But it's not a matter of negligence, but you want to get that product out the door. So we realized when we started to look at this as the cloud team that we really had a lot of difficulty like inventorying and tracking what components are being used by what applications. We had no system for categorizing resources. We didn't know what resources were being used by a particular project. Is this project using a load balancer? Is it using a database? Well, thing we forgot. It's also using like a CDN, a CrowdFront. And guess what? I think it stores logs in the S3 bucket. So, there's really, governance issue. We had a huge mix of approaches. So the focus was more on delivering the MVP, but, it mattered more how we get to the endpoint, but whether we use mixed technologies or stacks, I think that was much of a lower priority. Another important issue that we had was there were no standard deployment processes in place. So either some projects had like a straight pipeline from the developer's machine straight to production. And some applications didn't have a dev or stage environments. So the really crucial parts of having like a workflow. Cost saving, and you're probably all familiar with this, like when you're all spinning up resources in the cloud, so sometimes like you tend to forget stuff running, and then until you get the bill from your cloud provider, so like, oh, I forgot this thing running 24/7, and this is a large server with a large amount of memory, and it's costing us, So, and again, so we wanted the ability to have control and see, what we have. We wanted a canonical inventory. Patching and upgrades. You got to stay on top of security here. So you want your, like platform and tools and, software, anything that you use to stay up to date. So you want to make sure you patch and upgrade properly. So these are some of the problems that we needed to solve. So, SSH keys. So what I mean, so I'm going to go over these in each slide. The ability to tag resources, a canonical inventory, how we handle secrets, passwords, usernames and passwords, and API keys. So like, whenever you spin up an application, so it's probably leveraging some third-party service, and you need to access it via an API key, and that API key is secret. So how do you handle it? Do you store it in a local file? Is it an environment variable? I mean, is that environment variable available in all environments? How do developers test this locally if they want to? So, and again, some projects, an application didn't have a pre-production environment, so we had loose account control. So, it was really tricky for onboarding. So someone, who onboarded or joined the project, you would give them an AWS account. They wanted to be able to do a variety of things. So, and then it was just easier to give them like a variety, like a wide, span of permissions, versus like narrowing it down to just the stuff they need to access. So they basically, some had more permissions than they really needed to. So another issue is resources running all the time, and that costs money. So we needed to control that. So enter DevOps. So this is where DevOps comes in, like handy, and it solves these kind of problems. So where the operations are they're participating in the application building, configuration, and from the early stages, so that we are ensuring basically that the application is in a deployable, maintainable state. So basically, that's what essentially did. So, I mean, for you to be able, to excel or be successful within DevOps, so you definitely rely on tools. And for us, we're using Terraform. So we picked up Terraform to handle and manage some of our infrastructure in the cloud. And there are a variety of tools out there, a lot of tools out there that does track configuration as code. So I'm not going to go over those and compare them. So this is just a little definition and overview about Terraform. So essentially, you can write your infrastructure as code. So instead of creating resources, servers, RDSs, through the UI, when you're logged into AWS, you can do it all in code. Write some code, push the code. If you're able to push to GitHub, so you probably can build infrastructure. So So one of the issues we wanted to solve is like application ingredients. It's like what is this application using? What are the components of the application? So there was sometimes we saw these mysterious components of applications. So it was hard to map those resources, and we always wondered like what is the application recipe? Like how is this thing working? Like how to support it, to deploy it, to maintain it. I got to know what it is. So you have to identify what are the ingredients. So for you to, if you wanted to look at the ingredients of the applications, you have to go and figure this all out through AWS console. You have to log in. You have to go, for example, to CloudFront and look at CloudFront and see, do we have a cert attached to it or something? So you have to figure out piece by piece, but you could never get a full picture of what the application was using. So this is what Terraform comes in handy. So each app, each project uses Terraform to track all its resources. Load balancers, RDS instances, S3 buckets, and it's all in code. And this gives us the ability to track and review changes. I mean, it's code after all. So it's just easy for someone to look at code and you're changing, for example, an EC2 instance and bringing it up, like a much powerful one. You're able to see that. You're able to do that. Things like creating certificates. Like you are able to do that also in code. And also, once it is in code, I mean, it makes your infrastructure deployable. So the same way you're releasing software, like an upgrade for a particular tool, if you push code and you can release a new change to your infrastructure. So this is like what I mean by like an application or recipe. Like what are the components of an application? So this is like I trimmed things a lot here. So this is with Terraform. So let's say we have an application that needs a load balancer. So if you're looking at the code, you're able to tell that this thing is using a load balancer. Like resource AWS security group. Oh, we have a security group. Okay, let's say there's a requirement for you to shut down certain ports, open up certain ports. I mean, you're able to go directly and look at it. So like what ports do we have open from which CIDR blocks, which, cluster, and so on. These are just like a brief overview of how things look like in Terraform. SSH key. So it's whenever you create an AWS instance, so like you always have this pop-up window. So like, do you want to download this key? Where do you want to save this spam key? Okay, well, it's on my laptop. Like Joe wants access to the server, so like, what do? Do I just, Slack the key? Do I email it to you, or do I just like call you and give you all the number? So it was really tricky. So I mean, and sometimes these keys actually they can get lost or stolen. So which is an issue here. So they can be shared. I mean, sharing is caring, right? So. And actually, they were spread out across developers' machines, so it was actually like a security issue, so that we had to deal with. So, true conversation, real story. I mean, like myself and another developer. So did you try so and so's PIMs? That one didn't work either. I did this and still no luck. Blah blah blah. Is there a server that we jump into before we SSH into Superset? Superset is the tool that we use for dashboards. And then at the bottom, that's for the DB. Oh, I think we have a security group issue. So we went from a key then to, So, and a lot of organizations don't know how many SSH keys they have configured a lot of the time. So, and sometimes, I mean, they can end up on GitHub inadvertently. So, things that really keeps you up at night. So, who has copies of those keys? Sorry, who has copies or access to those SSH keys? Like Detective Bosch staying up at night. I don't know if you watch Bosch though, but so how did we fix SSH access? So we put a lot of restrictions, and we fixed it in a variety of ways. So one of them is actually, so you can't access the instance directly from your machine. So you had to authenticate to AWS and essentially use Session Manager. So by logging into AWS, you have your username, your password, your multi-factor authentication, and then you're able to do that. So that's one way of doing this. So Session Manager. Add in a bastion. So we had some servers that had direct access, like variety of ports open, straight SSHs from accepting access from everywhere. So we added a bastion basically to where developers can log into, and then they can head into other resources. And this is really super recent. We did this just very recently. So we started to use Bless. It's an awesome tool. It's basically an SSH certificate authority. So it runs as Lambda, and it signs SSH keys, and it's an excellent way to authorize users to access a particular SSH host. Built by Netflix, so you can imagine the environment this tool was built and tested in. So there's really no need for you to manage or configure authorized key files and who has access to those private keys. And you didn't have to go in and add each developer's public key in the authorized file. So, I mean, this SSH certificate authority is just amazing. So, like, the ability to use Bless was really locked things really further down for us. Mutable infrastructure, another issue. You want to be able to do some, machine learning or like anything. You want to be able to spin up a server. You go in, you create one through AWS. You get the biggest RAM possible, disk space, whatever, and then you start installing dependencies. Okay, you can install certain dependencies or libraries for the work that you're trying to do. You're just installing and upgrading things as you're going along. You're hitting incompatibility issues, and you address them as you go on, and you get things working. A day later, 2 days later, you get things working. It's awesome. It's been working for 2-3 months, whatever. But you don't have a way of rebuilding that server. You don't have a reliable way of rebuilding it. You don't have a canonical inventory of what dependencies you installed. So basically, your infrastructure changes all the time. So dependencies were manually installed. We didn't have. Just go over my notes here. Sorry. Yeah, and then sometimes you have like permissions. Like you install this tool. It needs to run as its own user. You create that user. That user has access to these folders, and it's writing logs to this location. And then you're trying to back up those logs somewhere else, send them somewhere else. You can't read them; they're owned by somebody else, and then you get into like a variety of issues. And a lot of the times, like once you get things working manually, I don't want to go back and touch this thing. I don't want to go back and tweak it, upgrade it, because I'm afraid it's just gonna blow the whole thing. Because I went through 5 or 10 days just trying to get this thing up and running. So, solution. So, we made every developer take an oath. I shall not create servers manually. So only, so we wanted immutable infrastructure. So we looked at a variety of tools for infrastructure as code, and Terraform handles immutable infrastructure really well. So we wanted a reliable way of, scaling the application. So we wanted to be able to use containers, and those containers had all the dependencies that were needed for the application. If there was a need to upgrade any dependency, there was a known process, so we would upgrade those dependencies and build that image, and we use that image to run our application. So immutable infrastructure. So really solved us a lot of the headaches, a lot of the gotchas, a lot of the unknowns. Issue number 5, loader environments. So as I mentioned, a lot of these applications were missing loader environments. Didn't have a dev, didn't have a QA. there was no reliable way of staging or testing changes. And sometimes, like your developers' machines are part of the infrastructure. So you're working on code and you ship it off right to production. So like you have a direct line. So we needed environments that mimic production. So basically to do our testing. Is anyone familiar with this? Works on my machine. This application is work on my machine certified. So the lower environment fix, so no more, we don't want to hear it. No more it works on my machine. So each application is project that we're spinning up, so we, by default, out of the box, it has a non-production environment. That's like a requirement that we need, it's part of the building and part of the architecture process that we have. So new ones are using non-production environments. We revisited existing projects and applications, and we kind of revamped them in a way that, give them the ability to benefit from a non-production environment. So this way, there are no surprises when your code essentially goes into production. So loose account control. So again, when you're onboarding members, developers, teams, engineers, so a lot of the times it's just easier to give access, and they have the access, but not the greatest, for security. We wanted a way to manage roles and permissions for each one who has access essentially to AWS. So we standardized roles and groups. So we standardized, we put in like a developer role, we put in a variety of roles, and we put people in different groups. And I believe we also had like dedicated roles to make deployments. We also had discussions back and forth. Do we want to have dedicated user or dedicated bot user per project that a user that has permissions to that application only? So that further locks things down, but it was just an idea that we were discussing. So this is related to security and how we wanted to protect the credentials and the username and passwords for AWS for developers. So, an engineer joins in, we give them access to AWS, they configure their command line utility, and now you know that AWS configure or credentials have those credentials in the clear. So we went a little further to protect that, and we're leveraging AWS Vault. So what AWS Vault is basically, it takes those credentials, encrypt them, and whenever you wanted to access AWS for whatever reason, so you had to load the creds from the vault, decrypt them, and make them available to you, and then you can, log in. Secrets issues. So as I mentioned, so whenever you have an app that's leveraging a variety of third-party or external services, or database, it's using a database. You need the username and password to access that database. It's also pulling data from, let's say, Google Analytics or any other third-party API. You have an API key, you got to save it. So we wanted a reliable, consistent way of handling those secrets. So we just didn't want to commit those keys, into the GitHub repo and push them up. And we had to solve that issue. So we use a tool called Chamber. So Chamber is a tool for managing secrets. So it stores them in the SSM parameter store. So I put a GitHub link over there. So this is how it essentially works. Excuse me. So, your containers or EC2s or ECS, essentially, it goes through Chamber. So it loads Chamber. Chamber goes out and read the credentials needed for the corresponding app and load them as an environment variable, and they are available to your code. So once your application has been spun up, so it already knows that a defined set of environment variables that made available by Chamber, and you can read them. So, but if you had to comb through all the GitHub repo, there is no trace of any API key. There is no trace of any username or password. So it's just loaded at runtime of your containers or EC2 instance. So, and it became a practice for essentially every project and every application. So every application had its own compartment. So it had its own area where it stores the credentials needed. It's also like a single source of truth when it comes to like what do we have for credentials or API keys for this particular project. So, or this key, for example, for whatever reason, got compromised. For example, you knew that you had to go to one place and one place only to change it. You had to rotate API keys, for example. So you didn't have to, you can go in and make that change in there and save it. So, and scheduling, another issue. So with having lower environments, sometimes they're left really running 24/7. So your folks leave at 5, at 6, at 7, and then, but it's not really necessary for those resources to stay running 24/7. So one way of saving costs is basically you want to shut them down in the evening. So we had a particular schedule, so we shut them down in the evening and also on weekends. So in order to save to save cost, and a lot of the times, just God forbid, in case sometimes those lower environments are not patched properly, are not upgraded properly, they're out of sync, they're out of date, they could be like a service where they can get attacked, basically. So, here. So what we did to control the scheduling is through tagging. So as you can see at the bottom, these are all the tags associated with a particular EC2 instance, I believe. And we had a schedule for it, and that's the time frame when the server starts and when the server shuts down. There's actually a utility that runs. We're part of there's a utility that runs and scans the AWS account and looks for those particular tags. And in EC2 instance that has those tags, it knows that it should shut it down. And early morning, it knows that it should bring it up to make it available. Tagging and ownership. So, a lot of time, again, when you create things manually through the AWS console, so the tagging tab doesn't get a lot of the attention. So, I want to get this thing up and running. So, maybe I will put one tag or two, but we had a very specific requirements from our executive office to basically tag our, resources, with the right, environment, what agency, what application that resource is part of, and who created it, and so on and so forth. So, consistency. Sorry, this slide should be here. Apologize. Skip that. Miscellaneous. So I wanted to, DevOps facilitates the maintenance and basically the maintenance and the deployment of applications and the support for those applications. So, and a lot of the success depends on tools. So we happen to pick Terraform, AWS Vault, Chamber, Bless, and a bunch of other tools. And it's really, I guess what I'm trying to say is it's really up to the team to choose the tools that works for them best. There are a lot of great tools out there. Terraform is one of them. AWS Vault is one of them. If you happen to use similar other tools, I'd love to hear about them. Success, is also dependent on collaboration within teams and and between teams. So we were moving at a much higher velocity. Having people all in one location on site, based in Boston, basically, and the standardization of things. So basically, if you do things, do it by standard. A formal way, a consistent way, doing it in the same way again and again. So, if you had one process of patching servers, whether you have a script or whether you do it through some other mechanism, as long as it's consistent, known, socialized to the team, and standardized. So that's what I mean by standardization. So consistent and socialized to the team, so each and well documented is also, that's another crucial part of things. So yeah, I think that's my last slide. Do you have any questions?
Yeah, can you just talk for a second about Chamber? And I kind of got, I didn't quite understand what that tool was and how it related to AWS Parameter Store exactly.
Right. So we'll go back to the slide. Yeah. So AWS offers a service called Parameter Store. You can go in and create like a value, a name and a value. For example, a user, production database username, production database password, and you store those. So they sit on the Parameter Store in AWS. Then you spin up an EC2 instance, or like, you have ECS, you have Docker, whatever, So your container is up and running, and at runtime, it knows that it needs to execute a utility. That utility is part of the container itself. It executes Chamber, and Chamber knows that it needs to go to Parameter Store and read a particular namespace. So we namespace them basically like, I just have an example here, like app1. So it knows that it should read that namespace, and anything it reads, it becomes an environment variable. So when the code is running, so whether it's like whatever programming language it is, each programming language has a way of retrieving environment variables, and those,
When you say that that's at runtime, is runtime when you're spinning up the container, or is it actually when the application is operating, it's continually going?
It's consistent. It is consistent. So as long as the server is running, as long as the container is up and running, that environment variable is there. It sits there. So any other piece of code that gets triggered, and it needs to go and fetch an environment variable with certain API key, so it's there. It's consistent. That's what I meant actually.
Don't you run into similar issues though, where users now have access to those environment variables?
Issues where
Instead of it happening at the runtime of the application, it's in the environment variables. Now, other users have access to those?
It helps the app to run. It has all the credentials it needs. As far as developers, we didn't really encounter a need where a developer really needed to have those environment variable accessible.
Right, but if they got access into those different environments, they went into the Docker container, they went into an EC2 instance, and even though they didn't have access to any of the actual environment variables there,
Yeah.
if they're in the environment variables on those instances, they could technically print them out though, correct?
Yeah. I mean,
Maliciously, they can still have.
Yeah.
maliciously, but again, they had to have a username and password. They had to have authenticated via multi-factor authentication. So there is some, if we had to go back for login. So I mean, they have access. I mean, once you have access, yeah, you'll if you wanted to, yeah.
And you can still easily reset the API keys.
Yeah, you can in case they get compromised, for example, you can go to the Parameter Store and just replace them. The app doesn't need to know that it has been replaced, essentially. So, I mean, you'll probably have to rebuild the containers that are spinning them up because they have to retrieve new. You have to reread the newly added key.
And I would think that the environmental variable would be short-lived. It's only at instantiation of the container. So then you'd have to have somebody going into memory to do a memory dump together. It would need to live.
Well, so at Docker.
That's what I would think, but
No, it's at it's at the life of the container. So as long as the container lives, whether it's shut off or it's turned on, it's in the environment variable. So you'd have to physically destroy the container and then rebuild it so that the new environment variable gets instantiated.
You don't actually have to rebuild it though. You just restart the container.
Yeah.
The way it
Okay.
works.
But
So
I see what you're saying, because I'm thinking in terms of pulling in, but it's got to drop it into the environment of the container itself.
Yeah.
So, yeah, it needs it at start, but Docker.
But
is
it
a little
sounds
bit
like
different, but I don't know.
it sounds like you have thought of that. If you restrict access to those environments, and it sounds like that in order for someone to really truly get in there, they would have to be trusted.
Yeah, definitely. Yeah. So there's got to be some level of trust. So
I was under the assumption that it happened at the runtime of the application as opposed to the runtime of the actual machine.
no, sorry if I was unclear about that.
So trying to see then, so you remove all of that, you've basically now got the middleman, which is Chamber, which is now your single point where the messaging backwards and forwards is going. So that chamber has access to all of your keys.
Mm-hmm. Yes.
What is chamber and how secure is that?
I'm sorry?
What is chamber and how secure is it?
So it's a good question.
Leaving your keys on the table almost.
So it's a great question. I don't know the answer. I don't know the exact answer. I mean, it's first of all, I mean, it is open source. I mean, definitely, it can be audited. I had to have been audited. I mean, it's also like everything else with open source. I mean, it doesn't mean that it's secure. It's verifiable. I mean, you can verify it. Did someone actually do verify it? Does it? At runtime, does it load more of itself from somewhere else and then maliciously harvest those keys and ship them somewhere else? But again, so if it did, in the event that it harvested, usernames and passwords and API keys, okay. So those usernames and passwords are just for that RDS instance, for example. I mean, I can give you those right now. So, API key is probably more risky there. So whatever third-party service or API, whatever data we're pulling, so maybe that's more risky. But if, as far as usernames and passwords, I'm not saying that this is, I'm not trying to minimize the risk here, but I think Rob had a comment.
Sure. Yeah, I just wanted to clarify the roles of different components in the system. So Chamber is actually just a binary that accesses AWS SSM parameter store. Parameter store is a place to put keys and values, and the values there are KMS encrypted.
Okay.
So you've got.
Like, are they not encrypted?
Yeah, they are.
Then that kind of mitigates. You get that, and
Exactly.
if you don't have any way to connect it, like that means nothing to you.
So you need access to both the encryption key, and parameter store has its own IAM policy stuff. So you need access to both the encryption key and the parameter itself.
But I think your question more was like, once they're retrieved and they're in the clear, what happens from there? Was that your question?
Well, it's just sort of understanding where the vulnerabilities lie in a system like that. How protected do you have to think? Does your thinking have to be when you come to architect a solution like this? What do I need to just be aware of?
Yeah.
I just like to know what the possible.
No, great question.
If I could get a instance to talk to your chamber instance, would it then have access to all your keys and all of that for all your kingdoms?
I mean, chamber is like it's a process running within the container. So you had to have, for example, have a username and passwords. You had to go through Bless. You had to retrieve or be provisioned a temporary SSH key. I mean, you had to have cross-lag. At that time, you know what? Just have, just take a couple keys. Yeah, I mean, it's really hard. Like, I mean, and again, if something happens maliciously, intentionally by someone who has access. I mean, once you have access, you do have access. You know what I mean?
I would also point out that under the parameter store access model, you typically give an application's IAM role access to a specific namespace in parameter store. So say only app one.
Yeah, exactly. Sorry, go ahead.
No, you're fine. So that actually leads me to a question. So in your diagram, you have everything kind of pointed to this central location. So it sounds like Chamber goes on each of those individual machines.
No, Chamber is, Chamber. Let's say you create a Docker image, you install a bunch of tools, and one of those tools is Chamber itself. So.
Yeah.
Right. So
Yeah.
does Chamber run as its own separate service, or does it run as an application on Docker, on ECS, on EC2?
It's a service. Well, let's define here. So, if you had to be in the container, you had to look for running processes. Chamber would be one of them, or Chamber would have been one of them that you ran and retrieved environment variables. Just if you do top or htop, you would see like a running process.
So it would run on each instance within an architecture.
Yes, exactly. Yeah.
Part of the Docker entry
Right.
point.
Yeah.
Okay.
Yeah. So.
And then do those instances get their own? They would get their own IAM like username and password.
Yeah.
And then from there, that's when they would get designated specific parameters that they would have access to.
Right.
Role, but yeah.
Role-based, actually. Yeah, I mean, like otherwise, if you don't have a utility that goes out and retrieve those keys for you, so I mean, where would you have those? For example, you had to have, for example, you have to commit those keys to your repository. You have to encrypt them. Your application now is running. Oh my God, I need to retrieve data from this API. Well, I need to read this file that has the keys, read the file, decrypt the file. Now the data again is in the clear. No, okay. Now you go out, you make that API call, you pull the data, and you terminate the connection, and then so what you have to have some sort of like self cleanup mechanism to wipe that stuff from memory, or like garbage collected or whatever, do something about it. And initially we looked at GitCrypt, I believe, one of them. So GitCrypt, so essentially you can encrypt files, but again, a lot of the times, I mean, if you are working out of fast space, and sometimes even if it's not out of fast space, you may inadvertently forget to encrypt the file before making the commit. So now you end up committing the file in the clear, so in your repository. So I think, it wasn't really an appealing solution for us that we had to go through these hoops, like, did I commit this encrypted, not encrypted? I have to decrypt it, like just all the projects should be like totally scrubbed off, like any sensitive information, username, credentials, passwords, anything. So start them in a place that is encrypted, and whatever tool you decide to use to go and pick them up for you. So, I mean, I think at least it's a much better security model, or a much better solution where we were once before. So at least we know where the credentials are. Versus like, well, man, where did you store these keys? I mean, well, it's in the INI file in the sub directory of this location. So, oh no, actually, that like it's in this environment variable, or it was also inconsistent. Like we had INI files. I mean, you could, some of them were hard coded in the code. So I mean, with this, you have a single place to look at things and. Make changes to them. So,
and then try expiring or rotating keys if everything is all over the place.
Yeah. I mean, I'm sure with API calls, I mean, you can just go in and I want to rotate my database password every week. I mean, probably overkill. Do I need to? But maybe you want to rotate other stuff in place. So, that's yeah, it's a good. I like the idea of the rotation. So, yeah. Yeah, that's not the icon of Chamber, by the way. They don't have an icon. If any of you is a design, like do a lot of design, or like you can volunteer and give them a PR with the logo. So that's Man in Black like icon. So don't be deceived at that. So
J.K. Rowling reference, right?
I'm
Chamber of Secrets,
yeah.
right?
Yeah.
Harry or somebody.
So yeah, but it's all like vault, chamber. Like it's all kind of theme related. So yeah. Any other questions? Any other questions, everyone? No? Cool. Well, thank you all. I appreciate it. Thank you.